Welcome to Module 3. In this module, we're going to provide an overview of the different deployment options that are available in IBM Cloud. We're going to cover topics such as Kubernetes, OpenShift, Cloud Foundry, and Cloud Functions. To begin this series, we're going to talk about Kubernetes. First, we're going to talk about containers, then we're going to talk about Kubernetes itself, then we're going to talk about how IBM Cloud implements Kubernetes. Finally, we're going to wrap up by showing a demonstration of how to use the IBM Cloud Kubernetes service. Thanks. Let's begin.
Before we talk about Kubernetes, let's take a look at containers. What exactly are containers? A container can be thought of packaging up your application's source code, dependencies like runtimes, binaries, libraries, and data. A packaged up container is called an image. Images are stored in what is called a registry. You'll see terms like images, image registry a lot when talking about containers. Before we get into the why, let's talk about the history. The term container may be new, but the concept of isolating processes has been around since the 80s, with FreeBSD jails in the 2000s being a popular example. The open source project Docker made containers an industry standard with simple developer tools that work on both Linux and Windows. Since then, there have been multiple container runtimes like Podman, CRI-O, and Containerd. There are many, many more. The container ecosystem has moved to adopting specifications from the Open Container Initiative, or OCI. Last up, we have image registries. These can be both private and public. We'll be getting into that a little bit more later. So why use containers? There are many reasons why. Here are a few. The first being that it's portable. You can run anywhere. Containers are abstracted away from the host operating system, making them portable. They can run uniformly and consistent across any platform or cloud. Next is speed and efficiency. Containers share the host operating system kernel and are not bogged down with extra overhead. This means you'll have faster startup times as your containers are inherently smaller in capacity compared to VMs. The last reason is security and isolation. Containers inherently prevent the invasion of malicious code from affecting other containers in the host operating system. Additionally, security permissions can be defined to block unwarranted components from entering containers or limit communication with unnecessary resources. Running a few containers on your own is fine, but what do you do when you're running hundreds or thousands? That's where you need a container orchestration. And that's exactly what Kubernetes is. Kubernetes is an open source project under the Cloud Native Computing Foundation, or CNCF. It's around 6 years old, has thousands of commits, and is a vibrant, well-supported open source ecosystem with many vendors contributing to the project. There are over 150 certified Kubernetes providers on the market today. The goal of Kubernetes is to make everything associated with deploying and managing your containers easier. It has automated rollouts and rollbacks. Kubernetes will automatically scale your services up or down based off of utilization, ensuring you're only running what you need when you need it. It will monitor the health of your services to prevent bad rollouts before things go bad. It will also continuously run health checks against your services, restarting containers that fail. Most importantly, Kubernetes is built to be used anywhere, allowing you to orchestrate deployments to public clouds, private clouds, on-premise, or hybrid deployments. We're going to quickly talk about how Kubernetes works at a very high level. The main way a system administrator would interact with Kubernetes is through the kubectl CLI. It's configured to talk to a specific Kubernetes cluster. Each cluster will have a master node and at least one worker node. Each worker node can support running multiple pods. Each pod is in turn running an image of a containerized application. IBM Cloud offers a fully managed Kubernetes service. In a matter of minutes, you can spin up your own Kubernetes cluster, have access to worker nodes, and start deploying applications. IBM Cloud's Kubernetes service has many benefits. 1. It's fully managed and provides automatic upgrades. 2. It's secure. The IBM Cloud Kubernetes service has broad industry compliance, including PCI, HIPAA, SOC 1, and more. 3. You can configure your cluster as a single or multi-zone cluster. Next are the supported add-ons. In just a few clicks, you can install a service mesh or serverless add-on to your cluster. Lastly, there's logging and monitoring. You can monitor and troubleshoot, define alerts, design custom dashboards, and more. Let's dive a little deeper on the IBM Cloud Kubernetes service. The IBM Cloud Kubernetes service can be deployed to any of the 6 regions on IBM Cloud. This includes North America East, West, South, the APAC region, Europe, and South America. There are different ways to deploy IBM Cloud Kubernetes service. The first is on a virtual shared instance. This will provision IKS on virtual machines. Next is a virtual dedicated instance, which is going to provide your Kubernetes cluster on a dedicated server. Recall that this is a single tenant instance. And lastly, you can provision your Kubernetes cluster on bare metal. Each type of deployment has multiple profiles, ranging from 2 vCPU to 512 gigabytes of RAM. The billing is hourly, monthly, or at the time of this recording, there's even a free option. There are two other services worth mentioning when talking about IBM Cloud's Kubernetes service. The first is the container registry. This is used to store container images in a fully managed multi-tenant registry. It's highly available as the service is hosted and managed by IBM Cloud. You can configure your images to be privately accessed by other users in your IBM Cloud account, shareable with API keys, or even make them publicly available. Images in the container registry will also be scanned by the Vulnerability Advisor tool. The Helm catalog is also unique to IBM Cloud and allows users to use Helm to install and upgrade complex Kubernetes applications in a cluster. The Helm catalog in IBM Cloud has access to IBM products, popular open source products like Jenkins and Tekton, and supports multiple architectures like x86, Power, and Z. So how does the IBM Kubernetes service work? How would you interact with it? At a high level, it would look like this. You'd first start off by logging into your IBM Cloud account. You'd select a region. You'd select a resource group. Then you'd list or push images into a container registry with the IBM Cloud CR images command. You can list or create new Kubernetes clusters with the IBM Cloud KS command. And you can interact with your Kubernetes cluster with the kubectl command. Up next, we have a quick demonstration of how to spin up a IBM Cloud Kubernetes service, access it, and deploy a sample application. The first thing we need to do to get started with Kubernetes on IBM Cloud is to spin up a cluster. To do that, we go to the IBM Cloud catalog, find our Kubernetes service, and start building our cluster. We're going to use 1.17, and we're going to deploy a single zone cluster in Toronto. We're going to go down to just 2 worker nodes. We're going to keep the default flavor of 4 vCPU and 16 gigabytes. For completeness, let's take a look at the other profiles that are available here. You can see you can flip through the bare metal and virtual shared and virtual dedicated offerings. Let's change our cluster name to SteveMar, something unique, and hit create. A few minutes later, you're going to get your managed Kubernetes cluster. Clicking on the overview and the worker nodes, you can see details about your cluster. Clicking add-ons, you can see the different add-ons that you can install like Istio and Knative. All right, let's run an application. I've downloaded a simple Hello World node application here, and we've logged into our IBM Cloud account. We're going to set the Kubernetes context to be specific to the new cluster that we've just set up here. And now we're going to run the CR commands, which are to log into the container registry, because we're going to be storing our containerized application in the IBM Cloud container registry. We can see the kubectl commands are already working. We can do get pods, get nodes, and we have information about our cluster. Let's take a look at our container registry. We've already run some of these commands, but let's go ahead and create a new namespace to store our images. Let's call it samples. Build our code locally with docker build, and we're going to tag it and upload it to the IBM Cloud container registry. You can see the new samples namespace has been created. Here we have some deployment and service YAML files. These are going to set the ports that are required and the image location. Let's go ahead and apply these YAML files. Let's issue a rollout command stating that our application has been rolled out. Let's find our external IP by running the get services command. Before we view the application, let's take a look at the embedded Kubernetes dashboard that's available. You see here we have 1 deployment, 1 pod, and going to the external IP, we can see our Hello World application running. All right, what if we want to make an update to this? What if we want version 2? Well, the first thing we need to do is update the code. And we need to rebuild our image and push it into the IBM Cloud Container Registry. Refreshing the container registry, we'll see that we now have 2 images in our namespace. And we're also going to update the configuration file to point to the latest version of our image. Let's reapply our YAML files. And let's run that rollout command again. Refreshing our external IP, we can see we are now running version 2. Just that easy. We can scale our containerized application to 3 deployments or 3 replicas. And if you're done playing around, you can go ahead and delete your deployment. This will slowly start to tear down all the pods and deployment files. To delete any images that you've put in your image registry, you simply go to the IBM Cloud Container Registry and start deleting things. Refreshing the external IP that we were given shows that the application is no longer running. And to delete the cluster, we go to the cluster overview page and delete our cluster. And this is a basic example of an end-to-end use case of playing around with the Kubernetes service on IBM Cloud. Let's summarize what we've learned. Containers are the building blocks for Kubernetes, and they provide process isolation. Kubernetes is an open source container orchestration project whose goals are to make deploying and managing containerized applications easier. IBM Cloud has a managed Kubernetes service that makes deploying and upgrading a cluster very easy. It is supplemented by the Container Registry and Helm Catalog services.